Good day, everyone. I'm Charlez Joaquin, and my final activity for vibration engineering topic is two degree of two degree and multi-degree of freedom. Introduction. A two degrees of freedom system consists of two interconnected masses, each capable of independent motion along a specified direction. The two degrees of freedom system finds applications in various fields, including mechanical engineering, civil engineering, aerospace, and robotics. It is particularly useful when analyzing structures or systems with multiple components that interact with each other, such as buildings, bridges, vehicle suspensions, and mechanical linkage. The behavior of a two degrees of freedom system is described using a set of coupled ordinary differential equations often derived from Newton's second law of motion. The study of two degrees of freedom for vibration allows engineers and researchers to analyze and predict the behavior of complex systems with interconnected masses by considering multiple degrees of freedom. A more comprehensive understanding of vibrations can be achieved, leading to improved design and control strategies for a wide range of applications. Next is types of two degree of freedom system. The first one is mass spring system. In this type, two masses are connected by spring without any dampers. The masses can move in one dimension, usually represented as horizontal or vertical motion. The springs provide the restoring forces that govern the system vibration. This configuration is often used to study the fundamental principles of vibration and their behavior in simple systems. Next is mass spring damper system. This configuration extends the mass spring system by including dampers along with the springs. Dampers introduce a dissipative force that represents the energy loss due to internal friction or external factors. The dampers can be linear or nonlinear depending on the system requirements. Mass spring damper systems are widely used to analyze vibrations in various engineering applications, such as vehicle suspensions, mechanical linkage, and building structures. Next is torsional system. In a torsional two degree of freedom system, the masses rotate about a central axis, usually represented as angular displacement. Springs and dampers are used to provide the restoring and dissipative torques that govern the system's torsional vibration. This configuration is commonly found in systems involving rotating components, such as drivetrains, crankshafts, and helicopter rotor systems. Torsional systems are essential for studying the dynamics of rotational vibration and ensuring the stability and performance of rotating machinery. This is the two degree of freedom system example. And next is applications. The first one is structural engineering. These two degree of freedom system are extensively used in structural engineering to analyze and design buildings, bridges, and other structures. Next is vehicle suspensions. The suspension system of vehicles often employ two degree of freedom configuration to provide a comfortable and stable ride. Next is mechanical linkage. Two degree of freedom systems find applications in mechanical linkage and mechanisms where multiple components are interconnected and exhibit complex motions. Fourth one is rotating machinery. Two degree of freedom systems are used in the analysis and design of rotating machinery, such as turbines, engines, and rotor systems. Last is aerospace and aeronautics play a significant role in aerospace application. They are used to analyze the vibration and dynamic response of aircraft structures, rotorcraft systems, and spacecraft. Next is the multi-degree of freedom systems. And the introduction. A multi-degree of freedom system refers to a system with more than 2 degrees of freedom, where each degree of freedom represents an independent variable that characterizes the system motion. The analysis of multi-degree of freedom systems involves solving a set of coupled ordinary differential equations that describes the relationship between the degree of freedom. These equations are often derived from the principle of Newtonian mechanics, such as Newton's second law of motion. Multi-degree of freedom systems engineers can optimize the design and analyze the system stability, develop effective control strategies, and ensure the safety and performance of complex mechanical and structural systems. Multi-degree of freedom systems provide a framework for analyzing and controlling complex motion and behaviors. By accounting for multiple independent variables, we gain a deeper understanding of the dynamics and flexibility of systems, enabling us to design more sophisticated machines, predict their responses accurately, and achieve desired outcomes in various fields of science and engineering. Next is the types of multi-degree of freedom system. The first one is mechanical system. These systems involve multiple interconnected mechanical components such as a robot arm, vehicle suspensions, or a vibrating structure. Next is robotic system. Each joint represents a degree of freedom, and the overall system behavior is determined by the combination of these degrees of freedom. Next is control system. Multi-degree of freedom systems refer to systems with multiple inputs and outputs. This system can be found in industrial processes, aerospace systems, and other complex control applications. Next is structural systems. Structural systems such as buildings, bridges, and towers can have multiple degrees of freedom due to their complex geometry and material properties. Next is molecular system. In the field of molecular dynamics, multi-degree of freedom systems are used to model and simulate the behavior of molecules and molecular assemblies. And lastly is the fluid system. Fluid flow phenomena often involve multiple degrees of freedom such as pressure, velocity, and temperature. And this is an example of multi-degree of freedom system, and this is an example of decoupling and controller design. And lastly, the applications for multi-degree of freedom system. The first one is robotics. Multi-degree of freedom systems are extensively used in robotics for tasks such as pick and place operations, assembly lines, and manipulation of objects. And next is mechanical engineering. Multi-degree of freedom systems are crucial in mechanical engineering for designing and analyzing mechanisms, machines, and vehicles. And next is structural analysis. Multi-degree of freedom systems are employed in structural analysis to study the dynamic behavior of buildings, bridges, and other structures. And for biomechanics, multi-degree of freedom systems are used to analyze human and animal movements. And for vibrational analysis, multi-degree of freedom systems are employed in analyzing and understanding vibrations in mechanical systems. Thank you for listening. That's all.